A baby's brain. Less than 1 pound of gelatinous tissue. And within its milky, convoluted folds, a universe of meaning. Emotions, ideas, memories, dreams, all will somehow find a home here, evolving and changing over a lifetime.
The ultimate machine and the ultimate source of everything. We understand the world the way we do because of the brains we have. We will understand the brain itself the way we will because of the brains we have.
The brain is the most complex thing on Earth. Even the brain of a baby is wildly complicated.
A piece of the brain, the size of a grain of rice, contains about 10,000 nerve cells, just in that little piece. You can just imagine how many pieces you have in your head. Within that 10,000 nerve cells, each nerve cell can make anywhere between 1 to 10,000 connections with other nerve cells. So there are something like 1 trillion connections.
It's almost overwhelming to think about the whole thing. If you think about how the whole brain and nervous system gets assembled, you know, you just want to throw up your hands and say, it's way too complicated, we're never going to understand it. The brain is the seat of our consciousness, of who we are. And in understanding where it comes from, we understand where we come from.
By 24 weeks, the vital organs of the fetus are well formed. The primitive heart can beat on its own. The once powerless lungs are now prepared to fill with air. And the brain has nearly its full complement of billions and billions of neurons, reaching out to each other, building connections with mind-boggling speed, nearly 2 million every second, until the brain has become a tightly packed network of trillions of crisscrossing wires, with more connections than stars in the sky.
You can imagine the size of the wiring problem. So how is that problem solved? How is that achieved during development? How is it that each one of those trillion connections is made appropriately?
You might think, oh, what a mess. It's just going to be a jumble of connections and wires all over the place. But in fact, the nervous system seems to have a strategy.
The strategy is in the genes. The brain begins to wire itself by following a precisely specified genetic blueprint.
The connections are following very defined rules. You know, go out of the eye, turn right at the optic chiasm, cross the chiasm, head toward the lateral geniculate nucleus, grow into the lateral geniculate nucleus. Don't grow into the medial geniculate nucleus because that's an auditory structure. So you can imagine the first stage of brain wiring is kind of like solving the problem of connecting phones in New York to phones in Boston. It's making sure that you're making connections between Boston and New York and not Boston and Washington, D.C. And that's all specified genetically. Now then there's a second phase of brain wiring. Let's say you want to place a phone call to your grandmother in New York. And you want that phone to ring, you know, on Park Avenue and 47th or whatever. And you don't want the phone to ring up at the Waldorf Astoria. Okay, how do you get that precise phone to ring? That's the second phase of brain wiring. If you place a phone call to your grandmother early in development, her phone will ring. But so will a lot of other phones. So there are a lot of connections that are made. If the connections are correct and being used, they get strengthened. If they're not being used, or they're only being used occasionally, they're lost. We could call it use it or lose it. So the fetal brain is really a dynamic structure that's constantly changing in response to this process of strengthening appropriate connections and pruning inappropriate connections.
Eventually, there will be trillions and trillions of connections between cells, charged with electrical pulses rippling like lightning storms across the hills and valleys of the brain's deeply furrowed tissue. Every cell in its place, every link between cells carefully organized. Nothing random, nothing arbitrary.
What we would really love to understand is how the brain, during development, generates millions and millions of neurons, sends them to the right position in the brain, and then somehow instructs each of those individual nerve cells to form very, very specific connections with one another.
A child's brain. A swirling profusion of billions and billions of neurons, reaching out to billions more neurons to form trillions of connections, pulsing with electric and chemical energy.
Exuberant connectivity. The cells literally are going wild making all these connections, discovering each other, forming the basis of what we call something learned. Learning is about connection and connectivity.
For a child just learning to read, even a single letter will set off a complex series of reactions. The brain begins by focusing its attention on the reading task itself. Then, it captures a visual representation of the letter and sends it to the areas of the brain where the visual symbol gets hooked up to the letter's sound and meaning.
You start with a block of marble, like a sculptor would, and there's a lot of marble there. A young child has hundreds of trillions of connections in the brain, twice as many connections as the adult. And then comes along the sculptor who takes away bits of the marble to reveal a form. Experience is the sculptor. Experience determines which of those connections to take away and which to leave. That's what learning is. It's changing the weights of the connections in the brain depending on experience.